Okay, so again, here's our secant tangent theorem, and that says that if you have an angle with the vertex on the circle, one of its sides is a secant, the other is a tangent line. Again, just the basic is if you have an angle with a vertex on the circle, this arc it creates, the angle is equal to 1/2 of the arc. So again, when the vertex is on the circle, here's our formula, the angle equals half the arc. So let's try that out with this picture. Here's our first one, find the measure of arc AC. So again, arc means to go on the curve of the circle. Start at A, go to C. So that's a pretty small arc. Notice we are given the angle that creates the arc, okay? This little angle here is 34 degrees. It creates our arc from A to C. So we use our, what's our formula say? It says the angle is equal to 1/2 of the arc. We have the arc. The angle is 34 degrees, and we want to know what arc AC is. So we need to solve this for our arc. To get rid of the half, we would multiply both sides by 2, and we have the measure of our arc is 2 times 34. Okay, so the measure of arc AC would be 68 degrees. Next, we're asked to find the measure of angle DAB. I'm going to go ahead and write 68 degrees in down here. Okay, this arc is 68 degrees. And now find angle DAB. So where is that angle? Again, wherever the middle letter in your name is located, that is where the angle is located. That's your vertex. So it's this angle here going from D to A out to B. So it's this opening here. Well, we can see we have the arc that it creates is 134 degrees, and we know that since we have a vertex on the circle for an angle, that the angle is equal to 1/2 of the arc. Okay, we do not know the angle. We're trying to find angle DAB, but we do know it's half of that arc that it creates, which is 134 degrees. So all we have to do is do 134 divided by 2, and we know that angle DAB is 67 degrees. Okay, so again, this angle in here is 67. Okay, so BC starts at B and goes to C on the edge of the circle. Now we have a problem here because we don't have the arc. We also don't have the measure of this angle right here. Okay, but one thing we can do is notice if we start at A and go all the way around the circle to A, how many degrees is that? A full circle is 360 degrees, correct? Okay, so right now we know this part of the circle is 134. We skip this section from B to C, and then this last portion is 68. So we know if we go 134 degrees and then whatever BC is and another 68, we get a full 360. So I'm going to set that up. 134 plus whatever our measure of arc BC is plus 68. Together those should be 360. And I can use this to solve for BC. It's whatever is left over to get to 360. So I'm going to go ahead and combine 134 and 68. And I get 202. So I have BC is whatever we add to 202 to get 360. That's the number of degrees left over for BC. Subtract 202 from both sides. I'm subtracting 202 from 360 to find out what's left for arc BC. And when I do, I get 158. Okay, so I found the measure of my arc. The measure of arc BC is 158 degrees. Okay, again, I found that. I'm going to go ahead and put this on my chart now. I found that by knowing I needed a full circle's 360. I had everything except for BC, so I just found out how many degrees were left that were not accounted for. Right, and finally we're supposed to find the measure of angle BAC. That's our angle right here at A, going out to B and out to C. Notice we just found the measure of its arc, and we know that Since its vertex is on the circle, the angle should be half of that arc it creates. So our angle is going to be half of 158. So I take 158 divided by 2, and I get 79 degrees. So I was able to solve for all of those missing parts they wanted from my diagram using the property that if the vertex is on the edge of the circle, the angle is equal to half of the arc.